Okay. So today we're going to be looking at section 6.6. And we're actually, this is going to be the end of kind of basic trigonometry definitions and such. And we're going to be talking about law of cosine. All right. So last time we saw how to solve triangles using the law of sines. And we had three different cases we looked at. So the first case was angle, side angle, or side angle, side. Sorry, side angle, angle. And in both of these situations, we had triangles that weren't necessarily right triangles. In the first case here, again, we had an angle, and then we had a side, and then an angle. The second case over here, we had a side, an angle, and an angle. All right. So moving on to the next case that we looked at, this was side-side angle. This case was a little bit tricky because what we saw was that given a side, and an angle over here, there was three possible solutions. So this either had two solutions, one solution, or zero solutions. So something we'll see today in class is that whenever we're applying the law of cosines, you're either going to have one solution or zero solution. So it's a little bit easier in that sense. And let's just go ahead and review what the law of sine stated. It basically says that anytime you have the length of the sides of a triangle, they're going to be in direct proportion to the sines of the corresponding angles. And that gave us the following formula. So this is law of sines. So yeah, let me draw a triangle so that we can keep track of this. So we have, a standard triangle over here. A, B, and C. And the opposite side has length A, opposite side has length B, opposite side has length C. And we get that sine of A divided by A is equal to sine of B divided by B. And this is equal to sine of C divided by C. So this is what we looked at on Monday, but we had two more cases to look at that we didn't talk about. So yeah, let's go ahead and recall what these other cases were. So let me scroll down a little more. So the last two cases were side angle side and also side, side, side. So in this case, let's see why the law of sine doesn't work here. So here we have a side, here we have an angle, and here we have a side. And here we only have all the sides. So again, the reason why the law of cosine won't work in these two cases is, again, for the law of cosine to work, you need a side and the opposite angle, right? But here we don't have that. We have an angle, but not the side. We have the side, but not the angle. And we have the other side, but not the angle. So we need one of those because we only want one unknown. And the same thing for side, side, side. Here we have all the sides, but we don't have any of the angles. So we're always going to have at least two unknowns in the law of sines. So these are going to be the cases that we really look at today. And we're going to be applying the law of cosines here. And so let me go ahead and again draw another triangle so that we have a reference point. So here's our standard our obtuse triangle. So again, we'll call this A, B, C, C, A, and B. And the law of cosines for any triangle ABC is the following. So this is going to be the law of cosines. Okay. So this is going to state that A squared is equal to B squared plus C squared minus BC times cosine of angle A. And then we're going to have this relationship for every side here. So this is going to say also that B squared is equal to A squared. Oh, I'm sorry, there should be a 2 here. So this should be a 2. So A squared plus C squared minus 2 AC times cosine of big B. And the last one we have is going to be C squared is equal to A squared plus B squared minus 2 AB times cosine of C. Okay. So let me just point out a small pattern here. You don't have to memorize all these equations. You just really need to memorize one. So let's look at this first red one real fast. So if we just draw the first part of it, we have A squared is equal to B squared plus C squared. You can just kind of notice that this is really the Pythagorean theorem right there. So to memorize this equation, what you want to do is, again, just take this B and take this C and subtract 2BC there. And then you kind of have this correction factor that belongs to the length A, which is cosine of A. So really the difficult part is memorizing this, but you can memorize this by kind of realizing that you'll have B squared plus C squared minus 2BC, and then the remaining angle has to be from the left-hand side. I don't know any catchy phrases how to memorize that, but that's kind of how I memorize it. Okay. So yeah, we said last class that the law of cosines is a generalization of the Pythagorean theorem. Let's go ahead and see why this is true. So let's say, again, we have law of cosines. Okay. So let's suppose we have a right triangle. Looks something like this. And let's call this angle here. So we'll break this up a little bit. We'll call this C. We'll call this angle A, and we'll call this B. So this is going to have side C, side A, and side B. So if we apply the law of cosines to this right triangle, we want to apply it to this angle of 90 degrees. And so we're going to get C squared is equal to A squared plus B squared minus 2AB times cosine of big C. And now if we fill in what we know that cosine of C should be equal to cosine of 90 degrees. So we're going to get that this is equal to a squared plus b squared minus 2ab cosine of 90 degrees. So cosine of 90 degrees is just 0, and we get that this is going to be a squared plus b squared. Okay. So the Pythagorean theorem is embedded inside the law of cosines, and this is just one way to obtain the Pythagorean theorem. But I think, so I'm not sure about this, but I think the Pythagorean theorem was known first, and then afterwards we found out about the law of cosines. Okay. So that's kind of the entire content of the section. So what we're going to do now is we're just going to solve some right triangles. So I have a few from, again, the Law of Sine assignment. So let me just enlarge this a little bit. Okay, so this is going to be number 6.6, number 12. And we want to go ahead and solve the following, if possible. Okay. And so in this case, we have a right triangle. And we can just go ahead and label the angles A, B, and C again. And what we're given is just the sides. So this is going to be 12, this is 40, and this is 45. And so, again, you can kind of do this algorithmically. So the first thing that you can do is try to decide between law of sine versus law of cosine. So this is kind of an optional step. Most of the time, Law of Sine tells you which one to use. But let's go ahead and try to decide which one to use. If we did want to use law of sine, we'd need at least one side in the opposing angle. So we have a side but no angle. We have another side but no angle. And we have the last side with no angle. So we can't possibly use law of sine here. So we want to use law of cosine. Okay. And so if we apply law of cosine, maybe let's just first look at the equation. A squared is equal to b squared plus c squared minus 2bc times cosine of big A. And so what we do know from this equation is we know what A is, we know B, we know C, we know B and C, and what we're trying to find is big A over here. So we're trying to find this big A. So we're just going to plug in all our values and then solve for A. Yeah, let me scroll down here so we have some more room. So plugging all that in, we should get 40 squared is equal to 12 squared plus 45 squared minus 2 times 12 times 45 times cosine of A. All right. So we're going to go ahead and subtract both of these values from both sides, and we'll get 40 squared minus 12 squared minus 45 squared is equal to a negative 2, 12, 45 cosine of A. Okay. And so again, we're just trying to solve for A here. So let's go ahead and divide both sides by this leading coefficient here. Scroll down a little bit. And what we're going to get on the left-hand side is going to be 40 squared minus 12 squared minus 45 squared divided by a negative 2 times 12 times 45. And this is equal to cosine of A. So yeah, the law of cosine is a mouthful to say. There's a lot of numbers here. But, instead of showing you this calculation here, I'll let you do that on your own. And what you should get from the result of this calculation is about 1.0159 is equal to cosine of A here. Okay, so we're actually at the first difficult step here. We have to be a little bit careful now because remember, this is a trig equation. And so we want all solutions. Oops. Between 0 and 180 degrees, since we're actually working with a triangle. So let's go ahead and take cosine inverse of this. So finding one solution, we'll cosine inverse of 1.0159. This is equal to A. And plugging this into a calculator, we'll get that this is about equal to 58.2 degrees here. And so again, normally we want to find the other solution. And so you would think, okay, well, this is going to be just like sine. What we want to do is we want to find the other solution in the second quadrant here. So if I wanted to find the solution in the second quadrant, so let me write a disclaimer that this is going to be an error. So we're going to produce an error real fast. So you would think, okay, take 180 degrees and subtract 58.2 degrees from it. And this should be our other solution. Okay, so that's not correct here. Does anyone know why this is not a solution? So this is really the difference between law of sine and law of cosine. It's really this trig equation that we have right here. And so this is actually kind of tricky. So remember, anytime we're solving trig equations, in quadrant A, everything's positive. Quadrant B, only sine's positive, cosine, and then tangent. So the reason why this can't be a solution is because this is a non-negative angle here. But cosine has to be negative in quadrant 2. And so this doesn't solve the equation upstairs. So this is not a solution. Since the solution, or sorry, since this equation has to have only positive numbers, or sorry, positive angles to solve it between 0 and 180 degrees. Because we're working with this triangle, we don't want negative angles here. So the real key difference is that, I'll just make a quick note of this, the law of cosine has only unique solutions or no solutions. So we're still working this problem out, but this is a really important thing to note because this was something we had to deal with law of sine. The law of sine has multiple solutions exactly because the trig equation like this upstairs. Okay. And yeah, I'll repeat this after the problem's over again. But the thing to take away is that you don't have to worry about finding more than one solution for the law of cosine. All right, so we found, let's see here. Okay, we found A. And if we scroll back up, let's see here. Yeah, so we found A, and now we just need to find B or C. And if we can find one more angle, then we're done because we know the sum of the angles of a triangle add up to 180 degrees. So now that we have an angle here, you could apply the law of sine, or you can just apply the law of cosine again. Let's do the law of cosine. Let's see. Let's do it on B here. So let's scroll back down. Okay. So again, we're going to have B squared is equal to A squared plus C squared. minus 2ac times cosine of big B. And let me fill in what we do know. So we know B is 12, A is 40, and C is 45. So then we're going to get A times C is going to be 40 times 45 times cosine of B here. Okay. Again, we're just trying to solve for this B. So let's go ahead and do that. Subtract this from both sides. And we get 12 squared minus 40 squared minus 45 squared is going to be equal to a negative 2 times 40 times 45 times cosine of B. All right. Now dividing both sides by this coefficient, we'll get 12 squared minus 40 squared minus 45 squared divided by a negative 2 times 40 times 45. And this is equal to cosine of B here. All right, so applying the inverse to both sides, we'll get cosine inverse of this number. And this is going to be equal to B. So I recommend, again, first when you're plugging this into your calculator, go ahead and compute whatever this number is, and then take the inverse. And what you should get out is that we'll get cosine inverse of 0.9669 is equal to B, which is equal to 14.772. Okay, so we found B here. And so the last thing that we need to find is our angle C. And C is equal to 180 degrees minus A minus B. So this is going to be equal to, let's see, 180 degrees minus, I think that's 58.2 that we found. And we can just round this up to 0.8. So let's say 14.8. And this is equal to 107 degrees. Okay. So again, the thing that I want to just note is the difference between law of sine and law of cosine. So since cosine theta is positive only between 0 and pi divided by 2 in the given interval 0 to pi, what this says is that any trig equation, so trig equation in the form, let's say, call alpha a number, is equal to cosine of theta, this is going to have a unique solution. Okay. So yeah, let's look at a few more problems. Let's see. Let's turn on question 6.6, number 18. Okay, yeah, I see. Six point six, number 18. All right. And so this time again, we're going to solve the following triangle, if possible. So it's actually really nice to have this phrase here, if possible, because if we don't have a solution, then we're going to find out pretty fast if there is a solution or not. Okay, so let's inscribe the information that we have. We have, call this 35. We have this as 22. We have this as 52 degrees here. And let's just keep, the common convention. This is angle A, this is B, this is C. So this is equal to little a, this is equal to little b, this is equal to little c here. Again, let's just quickly pick between the law of sine versus the law of cosine. So if we're looking for the law of sine here, we need an angle and a side. So we have an angle but no side. We have a side but no angle. And we have another side but no angle. So we can't actually use the law of sine here. We have to apply the law of cosine. Okay, so this is a little bit different than the last problem because we have to make sure we choose the right sides and the right angles here. So let's see. So basically, we want to shoehorn the law of cosine so that we have only one unknown in the equation. And remember, so let me scroll way back up to the top, back to where we just looked at the law of cosine completely. Okay, so here was our equations. So whenever you're trying to decide which one you want, again, what you want is you want a side and an angle here. So if you have one of those and the other two sides, then you're good. So let's scroll back with this information. And okay, here's our picture of our triangle. And so what we see here is, again, we have a side here, but we don't have the angle. But we have the other two sides. And so what that means is that we apply the law of cosines to this specific situation, and we're only going to have one unknown in our equation here. Okay. So this is going to tell us that we have c squared is equal to a squared plus b squared minus 2ab times cosine of big C. So another way to do this is you could just write out each of the law of cosines and see which one has the single variable in it, or sorry, the single unknown, and solve it that way. That's another way you could do it. But now, sorry, let's now plug in what we know. So let's see here. So the only thing we don't know in this equation is actually the left-hand side. So we'll plug in everything else. So we're going to get c squared is equal to 22 squared plus 35 squared minus 2 times 22 times 35 times cosine of 52 degrees. It's 52, right? Yeah, okay. And so we'll simplify this piece of information here and also this piece here. So c squared is going to be equal to 1709 minus 770 times cosine of 52 degrees. Okay, and so simplifying this left-hand side here, again, we'll get c squared is equal to 1234.94. And so now we can finally find what our side C is. C is going to be equal to plus or minus the square root of 1234.94. And this is going to be equal to just about plus or minus 35.141. Okay. So how do we decide between a plus or minus here? Any ideas? Well, again, let me scroll back up again. So we're working with a triangle here. And this triangle is an abstract triangle. It's not anywhere. And so we don't have abstract triangles with negative negative sides or negative angles. So we don't even have to worry about plus or minus. We don't want the minus at all. And our solution is just going to be 35.141. Okay, so I think we found the side. So let me scroll back up. And let me just write this in. I'll write it in pink. So this should be equal to 35.141. And so again, we could apply law of sines because we only need to find our angle A here and our angle B. But really, the choice is up to you what you want to find. I guess we'll just go ahead and do A real fast. So scroll down. So applying the law of cosine again, we have A squared is equal to B squared plus C squared minus BC times cosine of big A. And so the thing that we don't know in this equation is our angle here. So we just found what C was. So let's plug everything in. And we'll get 22 squared is equal to 35 squared plus our 35.141 squared minus 35 times 35.141 times cosine of A. Okay. And so again, we want to solve for cosine of A. So first, subtract each side by this sum here. So that would be step one. And then in step two, go ahead and divide both sides by this coefficient. And so what we'll get then is 22 squared minus 35 squared minus 35.141 squared divided by a negative 35 times 35.141 is equal to cosine A. Okay. And so the left-hand side of this equation, so if you simplify this down, you should get that this is 0.8032 is equal to cosine of A. And so taking the inverse of both sides, we'll get cosine inverse of 0.8032 is equal to A. And this is about equal to 36.55. Okay, so we have A is going to be 36.55. So the last thing that we need to do is, let me go back up here. We have our A, the only thing left is this B here. And again, B is going to be equal to 180 degrees minus the sum of the other two angles. So minus A minus C. So plugging in what we know for A and C, we'll get 180 degrees minus 52 degrees minus 36.55. And this is about equal to 91.45. Okay. And so we're done here. So let's do one more law of cosine, just so that we see another type. And then we'll jump to a different type of problem. Okay, so this is question 6.6, number 18. And again, we want to go ahead and solve the following if possible. And again, we have our triangle here. We have, just label this information. Okay, and the things that they give us is they give us that little a is 65, little c is 50, and angle C is 52 again. Okay, so again, we're going to pick whether we want to use law of sine or law of cosine. So I mean, in this case, we're still going to use law of cosine here. Or I guess we can use law of sine. So we have this 52 degrees here, and we have this 50 here. So we can apply law of sine here. And let's see. Can we apply law of cosine? So we have a side, and an angle. Yeah, so we can also apply law of cosine here. But I think it would be easier. Let's apply law of sine. So we want to apply law of sine to angle C and side C and angle A and side A. So this is going to be sine of C divided by C is equal to sine of A divided by A. And plugging in what we know, sine, so C is going to be 52 degrees. Side C is 50 degrees, sorry, 50. We don't know what angle A is, and we have that side A is 65. So we want to solve for angle A here. So multiply both sides by 65, we'll get 65 divided by 50 times sine of 52 is equal to sine of A. So simplifying this coefficient in front, we'll get this is 1.3 times sine of 52 degrees. And plugging this into our calculator, we'll get 1.3 times 0.788 here, and this is sine of A. And this is about equal to 1.02 here, sine of A. Okay. And so remember that the sine of A always ranges between -1 and 1. So this can't be equal to true. Sorry, these can't be equivalent. And this says that we have no solution. So we did this using the law of sine, mainly because I don't like writing out a bunch of numbers, but you could equivalently do this with law of cosine. Okay, yeah. So this triangle actually doesn't exist, so no solution. Okay, so let's look at one other problem here. So this is going to be on the quiz. And this is going to be Perron's formula. So this was introduced in the lecture videos. And basically, this just allows you to find the area with only the sides. Find area of a triangle. So again, let's just suppose that we have a triangle here. And we only know the sides here. So this is side A, this is side B, and this is side C. Then we can find the area of this triangle with the following formula. So this is going to be the area is equal to the square root of S times S minus A times S minus B times S minus C, where we have that S is equal to 1 divided by 2 times A plus B plus C. Okay, and let's look at a problem involving this. Let me scroll down a little more. So this is 6.6, number 35. And we want to find the area of the following figure. Okay, and so we'll come back to this formula in a second. Let's scroll down. And this is the figure we're looking at. So it's a little bit of a diamond shape. It's a little bit off though. And let's say, let's call this side length 6. This will be 7. This has side length 8. And this one has 9 here. And the only other thing is we know that this angle here is 100 degrees. Okay, so we want to find the area of this figure here. Using Heron's formula specifically. Does anyone can anyone see how to do this? So we don't have triangles, but we do have triangles in the picture, right? Right, yeah, so we want to draw the line in the middle here. And we want to find the area of the top triangle, find the area of the bottom triangle, and then add them together. And that's going to be the area of the entire figure. Okay, so let's see here. So we have 2 triangles here. We have our upper triangle. So 6, 7, and 100 degrees. And we have our lower triangle, 9 and 8. And the thing, again, that we want to find is we want to find the area. And to do that, we have to have all sides of the triangle. So we need to find what this unknown is. Let me just call it x. But again, this x is going to be equal to each other in both of the triangles since we just bisected our quadrilateral here. Or not quadrilateral, but polygon. So if we can find what x is using this triangle, then we already know what x is going to be for the bottom triangle. So yeah, this is where we're going to, again, just apply the law of cosines because we have an angle, but not the opposite side, but we have the other remaining sides here. So again, let me just write it out. So we have a squared is equal to b squared plus c squared minus 2bc times cosine of big A. And so in this case, this gives us that x squared is going to be equal to 6 squared plus 7 squared minus 2 times 6 times 7 times cosine of 100 degrees. Okay, simplifying this term here and also simplifying this term here, we'll get x squared is equal to 85 minus 2 times 42 times cosine of 100 degrees. And so we'll get that this is going to be equal to the square root of 85 minus 2 times 42 times cosine of 100 degrees. And I accidentally skipped this step in my computation, so I should just tell you the final answer. This is going to be 9.606. Okay, so let me scroll back up here. So we have x is about 9.6 or so. And that means that we can apply Heron's formula to each of these. So we'll find the area of triangle 1 first. So again, the formula is going to be that the area is equal to the square root of s times s minus a times s minus b times s minus c. And where we have that s is equal to 1 divided by 2 times a plus b plus c. Oops. Okay. So let's compute what our s is. So this is going to be 1/2 times 9.6 plus 6 plus 7. And this is about equal to 11.3. And then now we're going to find A1. So plugging in what we know, this is going to be 11.3 times 11.3 minus 9.6 times 11.3 minus 6 times 11.3 minus 7. And simplifying this, you should get that this is about 20.92. And so this is going to be our area for area 1. And this doesn't have any units, but if it did, it'd be units, whatever the units was, squared. Okay, so we're done with area 1. So we'll do the same thing for area 2. So area 2 again, just so that we can see it, let me write out the formula again. We have A2 is going to be the square root of s times s minus a times s minus b times s minus c here. Okay, and again, s is going to be equal to 1/2 times a plus b plus c. So it doesn't matter which a and b and c we use, but let me go back up here. And yeah, so this time our values, let's say that a this time is equal to 9.6. We'll let b be equal to 9, and c will be equal to 8. Okay. So this should be 1 divided by 2 times 9.6 plus 9 plus 8. And this is about equal to 13.3. All right. And so now we'll take this number along with our a and b and just plug it into this equation. So we'll get A2 is equal to the square root of 13.3 times 13.3 minus 9.6 times 13.3 minus 9 times 13.3 minus 6. Okay. And again, when you compute this in a calculator, you should get that this is about equal to 33 point, looks like this is a 9 here. And so the area of our parallelogram is again equal to the area of the upper triangle plus the area of the lower triangle. And this is equal to let's see here, 20.9 plus 33 point, oh, I'm sorry, this is actually a 4 here, 33.4. And so this is about equal to 54.3. Okay. So 1 second, let me go back real fast.